Perfect, you hit the record button. All right, great guys, thank you so much for being here. I'll present some findings today on crowdsourcing data analysis that I've been working on in collaboration with my co-author, Professor Benoît Monin. So first, I'll share a brief open science statement and links to all the available materials. Then I'll briefly define crowd science and crowdsourced data analysis and introduce our question of interest, which is, does crowdsourcing data analysis improve lay perceptions of scientific findings? And after that, we'll together go through the methods and results of an experiment that we ran to study this question. And hopefully we'll have some time at the end for discussion. If you have any questions, thoughts, or comments, please feel free to raise your hand or unmute yourself and jump in. We have quite some time today for the session, so I'd be happy to make it as interactive as you'd like it to be. All right. So in terms of the materials, they are all openly available online. That includes a pre-registration, the survey, data and code, and a fully reproducible manuscript. You can find all these materials on the OSF at the link on the slides. You can also find them on GitHub. And if you want to have these slides in front of you, you can also find them at bit.ly/many-analysts. So let's talk about crowd science. I think that Nicholas already gave a great introduction, so I'll keep it quite short. Crowd science is defined as the organization of scientific research in open and collaborative projects. And these projects can range from highly inclusive, such as when we source citizens, to highly selective, for instance, when we source specialists, like academics, which is what I'll be talking about today. You can use the crowd at different stages of the research process. You may have already heard of crowdfunding, which uses the crowd for funding, but you can also use a crowd of individuals for generating research ideas, for designing your studies, collecting data, and analyzing your data, which is what I'll be talking about today. And the birth of the citizen science movement is depicted in this painting right here, which was in 1833, when a scientist named Denison Olmsted used letter correspondence to recruit citizen scientists to help document a meteor shower. And this led to a detailed documentation of the Great Meteor Shower and the birth of the citizen science movement. So let's talk now specifically about crowdsourced data analysis. Crowdsourced data analysis involves giving different teams of scientists the same data set who independently analyze it to answer the same research question or estimate and report on a parameter of interest. It is also known as the many analysts or multi-analyst approach, and it has been on the rise recently in the social and behavioral sciences. So I'm including here an interactive table with 7 entries. And these are 7 papers that have recently been published in the social and behavioral science that use the many analyst approach. And I should say some of them are also preprints. They include interesting topics such as variability in replications, opinions about different social policies, the effects of gender and professional status of scientists on their verbosity during group meetings, variability in the analysis of fMRI, so neuroimaging data sets. And we can scroll all the way back to 2018 to a quite well-known study that Nicholas also referred to in his opening talk that looked at discrimination against darker skin tone soccer players and arguably started the recent crowd science movement in behavioral science. So what is the rationale of crowdsourced data analysis? Why should we be convinced by its findings? The phenomenon that underlies crowd science in general is known as the wisdom of the crowd. We know that individual judgments are associated with error, with idiosyncratic noise, but we also know that when we average over many judgments, that we can cancel some of that noise. And perhaps the first documented case of the wisdom of the crowd phenomenon was back in 1906, when 787 people guessed the weight of an ox at a farmer's fair. And the mean of all guesses was exactly true to the equal value exactly equal to the true value of 1,197 pounds. And it outperformed the estimates of cattle experts, and it also outperformed the individual best guesser who took home the grand prize that day. So I'll mention now some benefits of crowdsourced data analysis, some of which will overlap, and most of them are intimately related with each other. So first, crowdsourced data analysis can help us to diversify contributions to research. And I will say that this benefit is not specific to crowdsourcing data analysis, but a property of crowd science and big team science in general. So basically all the projects that we're talking about at the PSA. A goal of crowd science and big team science is to promote inclusivity and to include researchers from underrepresented institutions. And this, of course, comes with all the benefits of diversity. It allows us to leverage underused resources and skills. We, of course, can't all be an expert on everything, but if we recruit a diverse sample of data analysts, then some may have expertise, for example, on a certain statistical method that is most appropriate for the data at hand, or they'll have some other expertise that may benefit the data analysis. Second, the many analyst approach can help us to acknowledge that results in social science tend to be very variable and can depend on idiosyncratic choices that we have to make among multiple valid approaches. Sometimes these are even choices that we have to make unconsciously, such as the version of statistical software we rely on, or the different defaults in, for instance, SPSS and R. And it is important to note that the many analyst approach does not create this variability in results, it simply exposes it. So that should give us pause and epistemic humility when we assess conventional scientific research, which is often done by a single analyst or a single team. So the particular outcome you're looking at in that case is one from a distribution of outcomes that could have been possible if the analysts have made different choices. So like Nicholas said in his opening talk, approaches like this allow us to kind of explore the size of the multiverse of everything that could have been possible. A further benefit is that we can assess the impact of individual analytic choices on the results. So here we can ask if we can explain the strength of the evidence obtained by the specific individual decisions that researchers make. For instance, we can assess the impact of including or excluding certain control variables, the impact of running a certain statistical model, such as a t-test or a mixed effects model, or the impact of excluding or including certain participants or outliers. We could ask, for example, if people who obtain stronger evidence are more likely to do one or the other, and vice versa. Now, a fourth benefit is that the many analyst approach can help us assess the overall analytic robustness of a finding. We can assess to what extent a finding holds across many different analytic specifications. So we can ask, do the results come out consistently positive or consistently negative across all these different independent analyses? And when they do come out consistently positive or negative, then this can increase our confidence in the specific conclusion that we're drawing. Now, going back to the wisdom of the crowd phenomenon that we discussed earlier, another benefit is, of course, that we can average across all these idiosyncratic analytic choices to obtain more accurate parameter estimates and to balance out individual biases and errors in the aggregate. So now I'd like to move on to talking about lay perceptions. One of the reasons that crowdsourced data analysis was first proposed was to increase the credibility of scientific research. Now we know there's quite a great deal of science skepticism in some public circles, so we want scientific research to become more credible, not just to ourselves, but to lay people as well. And according to its proponents, this is exactly what it should do. Crowdsourcing data analysis should improve lay perceptions of scientific findings. So I'm including here another table with 3 quotes. The first one is from a pre-registration in which the authors justify their use of the many analyst approach by referring to the public needing to have faith in the conclusions of scientists. The second one is from a commentary on the many analyst approach, in which the author provides the hopeful view that crowdsourcing provides a new way to increase credibility for social researchers, not just among researchers themselves, but also among sample populations, and that it's hoped that the many analyst approach will increase public views of social sciences. The third one is from a preprint relying on the many analyst approach, in which the authors argue that many analyst studies that generate consistent results across independent analyses should offer consumers of scientific findings assurance that they are not arbitrary flukes. Now, these quotes, of course, describe a really worthy goal, which is to improve the credibility of scientific findings through crowdsourcing data analysis. However, this is also an empirical claim. And as far as I know, there's no evidence yet that crowdsourcing data analysis can indeed achieve this goal. So that's what we'll be looking at today. Does crowdsourcing data analysis improve lay perceptions of scientific findings? So to study this question, we ran an experiment with 3 conditions. These are 3 scenarios. The first condition is a conventional single analyst condition where a single team of scientists analyzes the same data set and reports a single aggregate parameter estimate of 5% for the relationship between 2 variables that I'll introduce shortly. We contrast this condition with 2 multi-analyst conditions. In the multi-consistent condition, 6 independent teams of scientists report 6 independent estimates that show low variance and high consensus. So they all agree in their conclusion, and the spread in their effect size estimates is small. In the multi-inconsistent condition, 6 independent teams of scientists also report 6 independent estimates, but in this case, they show high variance and low consensus. There's a large spread between the estimates, and the qualitative conclusions differ. 2 of the scientists find a negative relationship, and 4 of the scientists find a positive relationship. Now, it's important to note that in all 3 conditions, the given estimates average to 5%, and we then study the effects on posterior beliefs about the reported phenomenon, the credibility of the results, confidence in the precise aggregate parameter estimate of 5%, and the perceived impact of bias, error, or discretion on this estimate. And we define discretion to the participants as arbitrary choices between multiple valid approaches. And this is, of course, what we as researchers often refer to as researcher degrees of freedom. So very briefly, the experimental design. Participants are first introduced to a research question. Do religious people report higher well-being? And I actually drew from this research question from a recent in-progress many analyst project, the Many Analyst Religion Project. After they are introduced to the research question, they report their prior beliefs. So they answer the question, how likely do you think it is that people who are more religious generally report higher well-being? After reporting their prior beliefs, they are allocated to one of the 3 conditions that I previously described. And after reading the study results within the condition, they report on the outcomes that we've discussed. Now, in terms of the hypothesis, we base our hypotheses on 3 lines of thought. First, in line with social norms theory, we expected that observing consensus among a crowd, so the consistent crowd condition, would, compared to the conclusion of a single scientist, increase conformity in opinion. Now, second, in drawing from work on intuitive statistics, we also expected lay people to intuitively accord to the logic of the wisdom of crowds, the idea that several estimates can reduce noise stemming from individual bias or error. So if I, instead of seeing one person make a certain estimate or report a certain estimate, I observe 10 people report estimates, I know that the specific estimate that I see can't be influenced too much by bias or error, or at least the aggregate of the estimates. We hope that they are canceled out. And third, we did also expect a certain backfiring effect to variability. So in accordance with work that shows that it is difficult to reason about variation, not just for scientists, but to lay people, we predicted this aversion to variability. That is, we expected that observing variable estimates would decrease lay confidence in the precise average parameter estimate, And this is based on the idea that it may be completely foreign to lay consumers that analyzing the same data set can lead to different estimates in the first place. So if we report one estimate, this is taken to be the one true estimate. But if we report several variable estimates, the consumer in question may no longer be so certain that any of the estimates is precisely correct. So to summarize this, I'm showing here the pre-registered hypotheses in a table. This is the predicted direction of effects compared to the single analyst condition. So we always have the single analyst condition as our baseline, and we're looking at the effects within the multi-consistent and the multi-inconsistent conditions. We also control for prior beliefs, and you can find all these hypotheses at the pre-registration on the OSF. So our first hypothesis was that compared to the single analyst condition and compared and controlling for prior beliefs, that posterior beliefs would be higher in the multi-consistent condition. So when I observe a consistent crowd come to several estimates that agree with each other and that don't vary very much, I have higher posterior beliefs in the phenomenon, whereas we expected lower posterior beliefs in the multi-inconsistent condition with high variance and low consensus. We had the same prediction for the credibility, the perceived credibility of the results. For confidence, we had quite a different prediction in the sense that confidence refers to confidence in the aggregate parameter estimates, and we expected that observing variability, even if it's just a little bit of variability, seeing 5 to 10 different estimates would decrease confidence in the aggregate parameter estimate. And we expected lower ratings of bias in the multi-consistent condition, higher ratings of bias in the multi-inconsistent condition, and the same for error. We also had an exploratory measure of discretion simply because we really didn't have any prior work to base a prediction on, nor any intuition regarding how lay consumers would respond to a question about researcher degrees of freedom, but we were very interested in exploring this finding. So we pre-registered this as an exploratory measure. So I'll go through the survey materials now, the experience of participants through this study. They're first introduced to the study. So we tell them that we will ask their beliefs about a research question. We tell them that the research question is, do religious people report higher well-being? We give them brief information about how religiosity and well-being are measured. Then we ask them for their prior beliefs on a slider from 0 to 100%. How likely do you think it is that people who are more religious generally report higher well-being? We thank them for informing us and then proceed to the study design and research approach. In the single analyst condition, we inform participants about a single team of 6 researchers that together they work together as a single team to analyze the same data set, together make certain choices on how to analyze the data, and then report their joint findings. In the 2 multi-analyst conditions, we tell participants about 6 independent researchers who independently analyze the same data set to study the same research question, and each researcher makes their own choices on how to analyze the data and then reports their own independent finding. Now, it's really important to note here that in both conditions, we have a paragraph here, this last paragraph, in which we emphasize that there are a lot of choices to be made in scientific research. Participants also had to wait 30 seconds before they could proceed to the next part of the study. So then we move on to informing participants about the results. In the single analyst condition, we tell them that the single team of researchers concluded that religious people do indeed report higher well-being, and their specific estimate, they found that on average, for every 1 point increase in religiosity, survey respondents report a 5% increase in well-being. In the multi-consistent condition, we have the exact same sentence regarding their conclusion and their estimate, but in this case, it's an average. And they are also given the independent individual estimates of all 6 independent researchers. Now, as you can see here, we tell them that all 6 independent researchers do indeed conclude that religious people do report higher well-being. And these estimates right here don't range that much. So it's from 2 to 6%. So the spread in the estimates is quite small. In the multi-inconsistent condition, on the other hand, we first explained that there's a lack of consensus. So 2 scientists obtained negative results. They found that people who are more religious report lower well-being, while the other 4 scientists obtained positive results. And we give them these 6 estimates. And as you can see, there's quite a large range in these estimates. They range from -6 to 16%. They are told that the independent estimates average to 5%. We then measure our dependent variables. So the posterior beliefs question is formulated in the exact same way as the prior beliefs question, but we ask them this time after learning about the results of this study, how likely, etc. And then for the credibility of the results, we ask them the extent to which they judge the results, so how reliable they think they were. And if you read these results in a newspaper, how credible would you find them? For confidence, we ask participants how confident they are that 5% is the correct estimate of the increase in reported well-being for people who are more religious. And then we have a series of questions about which factors the participants think that may have had a significant impact on the overall estimate of 5%. The first factor is bias. So some researchers wanted to arrive at a particular conclusion. How likely is it that this factor has influenced the findings or the overall estimate? The second factor is error. Some researchers made some mistakes along the way. And the third one is the exploratory measure I described, which is discretion. Some researchers making idiosyncratic choices among multiple valid statistical approaches. At the end, we have an attention check in which we ask them to recall the scientific study that they read about. So let's move on to the results now. First, in terms of the participants, we recorded 2019 responses. We pre-registered that we wanted to end with a final sample of 1,500 participants, 1,500 valid participants after all the pre-registered exclusions, or that we would stop after 2 weeks. And in the end, we did stop after 2 weeks of collecting data and did not fully obtain that sample. We were 2 people short. So in terms of the 2019 recorded responses, we excluded 120 participants who attempted to take the survey more than once. Then we excluded 73 participants who were screened out prior to starting or did not consent. And finally, we excluded the 328 participants who failed or did not complete the attention check. And this left us with a final sample of 1,498 participants, 500 in the multi-consistent condition and 499 in the other 2 conditions, the single analyst and the multi-inconsistent conditions. So let's move on to the main results. For the results, we regressed all outcomes on prior beliefs and condition with the single analyst condition as the reference category. So all results that I will show you control for prior beliefs and show the results for the 2 multi-analyst conditions compared to the single analyst condition. So I will now walk you through each individual aspect of this figure. In line with our hypotheses, we found that lay consumers of multi-analyst studies with inconsistent results have lower posterior beliefs, and that's the estimate that you can see over here, which is a decrease of about 20 percentage points in their posterior beliefs. They also found the results less credible, had less confidence in the aggregate parameter estimate of 5%, and believed that the 5% estimate was more likely to stem from bias, from error, and from discretion. Now, this was all in line with our hypotheses. Of course, we expect that people who see a group of people disagree on something and report highly variable estimates, we expect certain backlash, and this is, in a way, a normative response. It's how I would respond too. Now, for the multi-consistent condition, we were more surprised by the findings. Contrary to our hypotheses, we found that lay consumers of multi-analyst studies with consistent results, so observing a consistent crowd, also led to lower posterior beliefs. That's the estimate that you can see right here. They believed the estimate was more likely to stem from error, the 5% estimate, And we found no significant effects on the credibility of the results, confidence in the aggregate parameter estimate, and the perceived impact of bias. For the exploratory measure, we did find that lay consumers of multi-analyst studies with consistent results believe the 5% estimate is more likely to stem from idiosyncratic choices. So here's another graph in which we show the distribution of prior beliefs and posterior beliefs by condition. So you have the prior beliefs in blue and the posterior beliefs in orange. So one comforting thing that we can notice immediately is that the distribution of prior beliefs is very consistent across the three conditions. So in a way, randomization did not fail. We know that people had similar distributions in terms of their prior beliefs before being allocated to one of the three conditions. Now, in terms of the posterior beliefs, you can see a very clear shift here in the distribution in the multi-inconsistent results, in the sense that people shifted left, their beliefs decreased, and you also can see a bump right here somewhere between 0 and 25%. Now, in terms of the multi-consistent condition and the single analyst condition, you can see in both cases a positive shift to the right. So it is worth noting on the basis of this figure and a post hoc pair t-test that while these many analyst studies, multi-analyst studies with consistent results perform worse or no better than single analyst studies on all of our measures, there is a significant positive effect of the findings on the posterior beliefs within the condition. So the beliefs in the research hypotheses are greater after reading the multi-consistent study results. And this finding clarifies that multi-analyst studies are not necessarily bad in absolute terms for lay perceptions. However, when comparing to the conventional single analyst scientific research, crowdsourced data analysis does not seem to provide an improvement in the sway and credibility of scientific research to lay consumers. Now, these are, of course, very preliminary findings. What we found in our study with our sample was that compared to a single estimate, we found no evidence that crowd estimates improve lay perceptions of scientific findings. But in line with all the great multi-analyst research that has been done before, we should remember that this is one possible study from one possible operationalization in the multiverse of results that we could have obtained. So in the future, we are really curious to explore whether it might be aversion to variability that explains these findings. So is it the fact that the idea that analyzing the same data set can lead to different estimates in the first place, so different varying estimates, is that so foreign that it leads to a certain backlash? We are also interested in exploring what the perceptions of scientists are. And we also believe that in the future, it is important for crowd scientists to consider how, for example, by drawing from research on science communication, how to tackle science skepticism and effectively communicate these variable crowd estimates to lay consumers. And I'm, of course, very happy to hear other people's thoughts on possible future directions or the limitations of the findings or any other thought or question that you may have. So thank you so much.
We have some time. If anybody has questions, you can unmute or just put them in the chat and I can read them.
Okay, since everyone is so quiet, I thought I'll just chip in to break the ice. Yeah, I think this is actually a very interesting phenomenon. I think that many analyst projects are something new, and we sort of want to know what the impact is on everyone. Yeah, but one thing I sort of thought about also, like when you said about it, because it's about religion. Religion is a very sensitive issue, right? And I think is this the project that Suzanne runs? It is, right? Yeah, it's Suzanne's project, right? So
it is,
yeah,
correct, yeah.
Yeah, so yeah, I think it'll be sort of good if this can be run on like bigger scale. Even if you want to look at what would people think about, even if you want to rerun the soccer study, right? Although I think Wharton is sort of trying to do something like that through the adversary collaborative. I think they're trying to like rerun that project in a different way. So I think collaborating on that aspect might be something worth contributing. Something that you mentioned about the perceptions of scientists, I think this is something also that is great because like we talk about lay people, but what about within the scientific community, how we can do that? Maybe a forecasting survey, something like that can be launched. It could be seen. I think Anna Drever does a lot of this work, so you can sort of see whether she wants to like collaborate on this or something. And when you sort of launch it out and you can compare the differences between lay people and scientists and sort of improve the credibility of science in that aspect. So that's something that you can look at. I'm just wondering if you're actually looking at inculcating other studies into this.
Yeah, great. Thank you so much for your thoughts and questions. So first, in terms of your point on sensitivity, in a way, I agree, although I think on the spectrum of, sensitivity of possible research topics, scientific findings, this is not at the far end of the extreme, right? We could have also ran a study on COVID vaccination or man-made climate change in the US, and then I think you would have found even more polarization in beliefs. And in the end, as scientists, we want to be able to report on sensitive findings as well and hope that they are credible even though they're sensitive. So that's my first thought on that point. Would love to hear more on the rerunning of the 2018 paper that you mentioned. I think you mentioned Wharton, so I'll reach out to you individually to hear more about that. So I agree that it would be very worthwhile to not just have one particular study to be looking at. I mean, especially since we're also embracing of the multi-analyst approach. The story behind this study is that I was involved in the Many Analyst Religion project, and there was a call for commentaries. So we thought this is a great starting place because one of the reasons that many analyst projects have been implemented is to increase the credibility of research, and not just to scientists, but also to lay consumers. So we thought it would be interesting to explore whether that was indeed the case for this particular project, but I'd be very interested to see other operationalizations and other scientific studies incorporated in this line of work. And I'm happy you bring up perceptions of scientists as well, because you've kind of mentioned exactly why I included that on my discussion slide, which is, in a way, we might be embracing a variability a little bit more, especially in the more quantitative fields in which there's schooling in statistics and variability, simply from the exposure to it in our work. So I would be very curious to see what perceptions are among scientists themselves.
Yeah, great. And I think that's amazing. Like, I think that many of us have seen many analyst projects, but no one has actually seen like, is it really much better? I think that's a question that we all had in our minds, right? We all run these projects, but how many of us actually see whether this actually works out? So I think that with you pushing this forward, I think it's amazing. And of course, leveraging on Benoît's advantage as well, right? Benoît has a lot of expertise in this area. Yeah. Right.
Yeah. Thank you so much. No, I completely agree with your points. I think, in a way, I personally am a big fan of the multi-analyst approach. And I think for us, we feel like we've learned something.
Sorry, that's my class.
That's okay. That's okay. But we feel, of course, that we've learned something when, even when there's high variability, but I'm not sure that's the case for other people who might be observing our results. Katerina?
Thank you very much for your presentation. I really love this idea. Wait, I try to lower my hands. I really loved the idea of multi-analyst approach. And once, because you talked about how scientists themselves, what they think about it. And once I even sent a paper around and said, oh, there is an idea of a multi-analyst approach. Maybe it would be really awesome to do it somehow. And I got no response. So my question would be, I don't know, there is no right or wrong question, but what do you think, how you can encourage other colleagues to do it? Because they, for sure, they know that's right. They know that's good. They don't have time, or maybe they think it will not bring as much as the resources they would have to invest into this. So how I could promote it within my colleagues?
I love that question. So I think my take on this is I fully agree with you that the multi-analyst approach is worthwhile. I think there's a really interesting perspective. If I recall correctly, it's in a paper on the crowdsourcing science approach. I think Eric Ullmann is the first author. And kind of the perspective that I've gathered from that is, even though the multi-analyst approach is great conceptually, you know, it's not as practical in every certain circumstance. So we need to acknowledge first that if you have colleagues who are a little bit more resistant to implementing the approach, that there might be a point they're making, which is, one, it's highly resource intensive, right? A multi-analyst approach are high cost. So it takes much more effort to have 100 teams analyze the same data set than to have one team do that, which is what we conventionally do. So I think there's it's worthwhile to first think about, when is the multi-analyst approach most worthwhile? And I think, for instance, when there's a certain finding that's already quite well established or highly cited, or, you know, part of the foundations of the work that we built on, I think then it's really worthwhile. If a lot of people agree this is an important finding and it's important to our line of work, in that case, I think it would be highly worthwhile to examine this multiverse, examine the variability in the results if we have several teams of scientists analyze the findings. So I think one way to kind of get some momentum is to propose to do it for something that's very central. I don't think it's a great idea to do for something that's still in the early stages, still exploratory. At that point, I think you might be better off to first do the research in the way that you would usually do it. I would also say I've experienced the same pushback, I think, that you have, and it's really worthwhile to find a community of people who think the same way. And for me, the PSA has been one of those communities, right? And I'm on Open Science Twitter, and I find a lot of suggestions on multi-analyst projects and the like. So sometimes, even when you might not find a big platform at your own home university or something like that, I would recommend reaching out to the open science community and finding interest there. Yeah.